In this question, I have the sector AOB with angle unknown x, and when you connect the sector together, it forms the curved surface of a cone, OA to OB. The height of the cone is 25 centimeter. The volume of the cone is 1600. What's the value of x? To find the value of x, I need to find the value of this side. The value of this side, which is the same because this is the radius, and the arc length, right? How do I find all of these? The radius here, if you just concentrated or just focus on the question, you fold this paper to make it this cone. So this length is actually your L slant height, which is also the radius of the sector. Okay, so to get the radius, to get the slant height of the cone, which is the radius of the sector, I need to first get the radius of the cone. Because when I get the radius of the cone and I already have the height, I can get the slant height by Pythagoras. Because this is a right angle. The height is perpendicular to the base, to the radius. So I'm going to use the volume formula. It's going to be volume is equal to 1 over 3 pi r squared h. Volume is 1,600. 1 over 3 pi r squared times height, which is 25. You then multiply by 25 for both sides. Multiply by 3 and divide. Multiply by 3 both sides and divide by 25 both sides. Is going to be 192 is equal to pi r squared. You divide by pi. It's going to be r squared equal 192 over pi. So the r is the square root of this expression, 192 over pi. So the square root of 192 over pi is 7.81 7640. This is the radius. To get the slant height, I'm going to use the Pythagoras, and I know that Pythagoras is going to be the hypotenuse equal to the square root of the square of both sides added, this side and this side. So the L is going to be 25 squared plus this number squared. You put it on your calculator. 25 squared plus 7.817640 squared. That's me. The length is 26.193806. You round to 6 decimal places, or we can say 3 significant figures or more. Okay, this is centimeters. So from the slant height here, I know that the slant height L is equal to the radius of sector. So also there is something I wanted to tell you, which is that this thingy here, this this circle's circumference is equal to the arc length. So to find the arc length, you need to find the circumference of this circle. So circumference of a circle is usually the arc length. It's going to be the circumference or base of the cone. So it's going to equal 2 pi r. So 2 times pi times the radius, which is this one. No. Wait. The radius, this one, my bad. They changed the color. What was the color? This one? I don't remember. Okay, no, never mind. Anyways, 2 pi times 7.817640 is going to be 49.119681 centimeters. So like this, I found the arc length, the radius, the value of the radius. So I can just substitute in the equation of pi or theta over 360 times 2 pi r times 2 pi r times 2r is equal to no, my bad. 2 pi r is equal to this 49.119681. This is the circumference of the arc when we add 2r. This is when we need to find the circumference of the total sector, but here I want to only find the arc length. So it's going to be x. You can write x directly, easier. So it's going to be 2 pi r. What is the r? Is the 7.8. X is equal 360 times 2 pi, the r, which is the slant height. This one, don't get confused. There is radius of the sector, which is the slant height, and there is radius of the circle itself here. 2 pi times the length, the slant height. It's 49.119681. And then I can divide 49.119681 divide 26.193806 divide 2 pi times 360. So x at the end is going to be 107. And that's it.